So part D is some way more trickier than part C, but I feel like it's doable if you approach it carefully. So we want to look at the hit rate of this inner loop here. Already we see that we have 6 axes, and these axes here may or may not be already in the cache. However, these 4 are definitely in the cache. And the reason is the cache is large enough to hold all 4 of these numbers. So let me just draw out the tag index and offset of A0, A8, and A16 to show you what I mean. So A16 or A0 here has an index of all zeros, an offset of 0. A8 has an index of 0, 1, 0, 0, an offset of all zeros. And A16 has an index of 1, 0, 0, 0, an offset of all zeros. When we access A16, we are not kicking out A0 or A8. Same goes for B0, B8, and B16. Therefore, these 4 here are always going to be hits. And this pattern continues for like A17 versus A1, A18 versus A2. It's like there's so much space in this cache that you can go 16 array indices back, and the number will still be in the cache. We don't have to worry about how far back you can go before you start replacing old items. We only care about AI and AI minus 16 and AI minus 8 here. And same for B. So now we have to figure out whether or not BI and AI are hits or misses. So because we increment by 1, we can use the pattern we derived in part C and realize that the pattern for these 2 must go miss, miss, hit, hit. The first 2 misses are because these are compulsory misses. And when we pull in BI and AI, we also pull in BI plus 1 and AI plus 1. So we can say for D, our hit rate is 1/2 times 4 out of 6 plus 1/2 times 1 to give us 5 out of 6 for our total hit rate. Now part E asks, what is the minimum cache associativity that results in a maximum hit rate for this segment of sequence? So if you look back here, we don't need to worry too much about cache associativity for just A. And we don't really need to worry too much about cache associativity for just B. However, if we were to have a one-way or like direct map cache, right? We have the ping pong effect, where A0 will get replaced with like B0, and then A8 will get replaced with like B8, and then A16 will get replaced with like B16. Thus, we can't have a direct map cache. So the answer is all one way. However, we had a two-way cache that we wouldn't have to worry about having both A and B being subjected to the ping pong effect. Therefore, we can say that the minimum cache associativity here needs to be a two-way cache associative cache.